Hello everyone, I'm D.M.KALAI SELVI, Assistant Professor, CSE Department, RMD Engineering College. Subject code is 21CS502, Artificial Intelligence, 5th semester in the academic year of 2023 to 24. Now we are going to see the difference between artificial intelligence, machine learning, and deep learning. So artificial intelligence, what we are doing is we are making the machines to work like work or behave like a human being using particular algorithm. But we are seeing for machine learning, so uses statistical methods to make the machine to improve their performance, or we can say it as their experience. Deep learning make use of neural networks similar to the neurons whatever available in our human brain and to imitate the functionality just like a human brain. AI is a super class, and under that we'll have ML and DL, that is machine learning and deep learning. ML is a subset of AI, and deep learning is a subset of ML. So some applications using AI examples or Google AI predictions, ride sharing apps like Uber, Lyft, and AI autopilot, etc. And then if you're going for ML, Siri, Alexa example, and then we have spam detections in the emails, malware filtering. So that will be an example of machine learning. And for deep learning, we have seen the sentiment based news aggregation, image analysis, caption, automatic caption generation, automatic code generation. So all that will be the deep learning. So now we are going to see about a non-parametric supervised learning algorithm for classification and regression task is a decision tree. So supervised algorithm, here we will be having our data with the labels. So you have both the classification and regression. So classification means we have a finite data set. Regression, then we have an infinite data set. So it's a decision tree is actually a hierarchical tree structure. We have root node, leaf node, internal nodes, etc. And then a decision tree can be able to represent the functions and takes input as a vector of attribute values and returns the decisions in a single input, single output value. Terminologies used here, root node. So root node is where the decisions tree starts. So it represents the entire data sets. So it divided into two or more homogeneous sets. So leaf nodes are the final output node. So root node will be the input and leaf node will be the output node. Splitting means that we are dividing the root node into sub nodes. So that will be called as, based on a given condition, we are going to split the, or you're going to branch it. And so branch or subtree will be formed by splitting the tree. Pruning is the so here if you want any unwanted branches or nodes available in the decision tree, pruning will able to remove it. So parent or child node, the root node of the tree will be called as the parent node, and the child no other nodes other than the parents, then we are called child nodes. So the nodes belongs to same parent are called sibling node, and leaf node will be the final output, and that will be the last node in the tree. For example, whether to wait for a table at a restaurant. So this is the query we are going to give that to a musician. For taking the decision by a machine, the list of attributes that we will consider as a part of input. So we first will go, what's the question is whether to wait for a table at a restaurant. So if not, alternate option is whether there is any suitable alternative restaurant nearby, that is other than this restaurant any other restaurant is available nearby. So we are going to see check the attribute of alternate. And next attribute is bar, whether the restaurant has a comfortable bar area to wait in. So we are waiting here, and we are going to think whether the restaurant has a comfortable bar area. And next we are going to wait. Then we are going to see whether it is a Friday or Saturday. Generally, in Saturdays, the restaurant will be full. So if it is a Saturday, means the waiting in a restaurant is a waste, or we go move on to the next one. So we are going to take a decision based upon it. Then hungry, whether we are hungry or not. If we are very hungry, then definitely we can't wait. We have to move on to the next restaurant. If we're not, means we can wait. Patrons, then how many people are in the restaurant? So, if I mean, even if it is none, we will be waiting outside that the restaurant may not be open. Some factors, some like that one. So how many people, some are full or none, so that we have to check. And next is the range, price range. So what's the price range? And next is raining. If it is raining outside, we can't go out for another restaurant, the other, so we have to wait here. And we also check whether there are any reservation available, whether all the seats are already reserved. Otherwise, if it's so, we have to definitely move to the next restaurant. Next is the type of the cuisines. So if it is a French or Italian or Thai, uh, so based upon the cuisines, we have to check whether we have to wait here or we have to move to the other restaurant. And wait estimate, so how long, so we can wait. We roughly, for example, if I can wait only for 15 to 20 minutes in the restaurant. If it is not working, then I will move on to the next. So each person, the waiting time will differ, whether it is less than a minute, 10 minutes, or less than 30 minutes. So we can check the wait estimate factor. A Boolean decision tree actually is drawn to assert the goal attribute to true. So your ultimate aim is to make the goal attribute to true, and if the input attribute satisfy one of the paths, and leaving to the leaf node with true value. So from the root node, we have to go to the leaf node with the ultimate goal that we have to get the value true. So the goal state is patrons equal to full, and wait state is 0 to 10 minutes will be classified as a positive. So we are given the condition that goal we can wait if with some certain attributes are true. So the attributes your patron should be true, full, and wait estimate to 0 to 10 minutes. So starting here, patrons full. So your patron should be full here. If you see, here, patrons is full. If it full, what's our wait goal? 0 to 10 minutes. If it is yes, and then if you're going next, we are going to check alternate hungry. If you're hungry, yes, means we're going for the alternate options, whether it's raining outside, yes or no. And if you're seeing for an alternate restaurant, and then whether it is we are going to check the date, I mean day, reservation, bar facilities available. Thank you.